All right, hello again. This is Mackenzie's Pre-Calc 11 students. Welcome to the classroom. All right, today we're going to continue on with factoring. If you can get your lovely notes out, we are going to look at factoring messy trinomials. No, I lied. Factoring simple trinomials. So that is lesson 2 in unit 3. So it looks like this. So these you will have learned, depending on who you had for Math 10, there's a whole bunch of different strategies. I'm going to go through this strategy called decomposition for the messy trinomials, and you would have maybe learned the box method and the crisscross method and all that stuff. The good news is for simple trinomials, you don't need to know any of those methods because the number in this position would help if I put the pen on. In this position right here is a 1. So remember how I said in the last video, we always write our terms in the order of the highest degree first, and then going down to the terms with no variables in them. Right, so sometimes it helps to rearrange your trinomial expression to ensure what you have, but we're going to talk about just the ones where the number in the A position is a 1. Okay, also just going to review some terminology. What we're going to work on is going in this direction, where we take that trinomial and we factor it into 2 binomials being multiplied together. So when we go from an expression that is all terms and they're being added together or subtracted together, and we go to 2 terms multiplying together, that is called factoring. When we take out the greatest common factor, if we do the opposite, if we take the first term and multiply it by the first term, and then take the first term and multiply it with the second term, and then take the second term and multiply it by the first term, and then take the second term and multiply it by the second term in a process called distributive law or FOIL or whatever, arrow method, whatever you want to call it. If we do that, where we multiply everything in the first bracket with everything in the second bracket, and then simplify or group our like terms, we end up with a trinomial, and we're going in this direction, expand. Okay, so we're going to be focusing on the factoring portion of this little manipulative cycle here. We're going to be focusing on the factor section, and there's a way of doing this. I'm going to show you the long way first. And you're going to see why we don't need to do the long way after. Okay. So the number in the A position is not written because mathematicians are lazy and we don't write the number 1. But there is a 1 there because if there wasn't a 1 there, we would write what it is. And if it was 0, then we wouldn't write it at all. So the number that's not there is a 1. So if we take the first number present and multiply it by the last number, we get a total of 6. So we have to find, this should hopefully ring a bell, 2 numbers that multiply together to give us positive 6. And those same 2 numbers have to add to this middle coefficient here, which is -5. I'm going to pause the video here and try to think of what those 2 numbers are. All right, so maybe not, you figure out the 2 numbers. They have a positive product, which means they have to have the same sign. They're either both positive or they're both negative. Because they add to a negative sum, it means they're both going to be negative. So 6, if you're not sure, you start with 6 and you go, okay, well, 1 goes into 6 6 times. 2 goes into 6 3 times, and then there's no other factor pairs because the next number, if I'm going down here, is going to be 3, and 3 is already on the other side, so I'm done. Now you look at those 2 numbers, which pair adds to 5? And hopefully you figured out it was these 2. So it's going to be -2 and -3. And you can just double check. Does -2 times -3 equal +6? Yes. Does -2 plus -3 equal -5? Yes. All right, we're good. So if you were using decomposition method, and again, we're not going to use this method for our simple trinomials where the number in the A position is 1, but I'm just going to show you the long way. So if we're going to break that up, that means that if we had expanded, this middle term is a combination of two terms that got grouped together. So we're going to break that middle term, that -5x, up into the two terms that were grouped together. That's why it's called decomposition method. Decomposition means to break up. Okay, so we're going to rewrite it. 1x squared minus 3x minus 2x plus 6. Now, we have to remember to put the x there because it's not just a -5, even though I just kind of was lazy and put -5 there. It's -5x. So the middle two terms have to have an x there, right? And then you see, well, I can't factor this whole expression with these four terms, but I can, if I just look at two at a time, I can factor those, just like we did in lesson 1. I don't know if you're going to hear these whispers when I look at the video, but let's hope you do so I don't have to re-record. All right, so the thing that's common between 1x squared and -3x is 1x. So again, the common factor goes outside, leaving you with what's left inside, and this simplifies to x times x minus 3. And then you take these two terms and you say, ooh, what's the greatest common factor between -2x and +6? Now, little tip, whatever symbol's here is going to be the symbol here. So it's not, we're going to do a negative factor here. So the largest number that goes into -2 and 6 is -2. So if I divide both -2x and 6 by -2, that's my greatest common factor. I'm left with positive x, and then positive 6 divided by -2 is -3. Then all of a sudden, this looks very similar to part 2 of lesson 1, where we have the same thing in two terms. Now they're very big, weird, kind of awkward looking terms, but that's okay. We don't hold it against our terms for looking a little awkward. So we're gonna divide both these terms by x minus 3 because both the terms have x minus 3 in them. So we end up with x minus 3 divided out, leaving us with x from our first term. And if we divide x minus 3 from our second massive term, we're left with -2. And here we go. Here's our answer, x minus 3, x minus 2. And you're going to kick yourself because you didn't have to do any of that work. Because if you notice something, well, I'm going to point it out if you didn't notice it, you have an x minus 3 and you have an x minus 2. What were the magic numbers that you found at the beginning? Well, -2 and -3. So all this lovely work that you did here, which you're going to have to do when the number in the A position is not 1, you don't have to do that. You can skip this. Yay, because the number in the A position is a 1. All right, so let's try B here. If you want to pause the video and give it a go before I go over it, please do so. Okay. All right, so first of all, the number in the A position is a 1. The second thing to always look for, is there anything you can actually factor out of all three terms first before we even get started? And the answer is no. All right, so now we're looking for two numbers that are going to multiply to what these two numbers multiply to. So 1 times -80 is -80. And those same two numbers have to have a sum that is the same as the middle term's coefficient. I didn't realize how much I relied on pointing at things until I had to change my ways. Not a fan. All right, -2. Okay, so the answer might not be directly apparent to you, and that's okay, because what you can do is you can just say, okay, well, what pairs of factors multiplied 80. Always start with 1. 1 times 80 will be 80, right? 2 times 40 will give us 80. 3 does not go into 80. 4 goes into 80. How many times? 20 times. All right, does 5 go into 80? Yes, it does. It goes in 6. 5 goes into 10. It goes in that once. So 3 is left over. 30. 5 goes into 30. There we go. 16. It was 16. I was right all along. Does 6 go in? No. Does 7? No. Does 8? Oh, yes, it does. Oh, it goes in 10 times. Oh, my goodness. That looks like I want that one. Okay. So now you're looking at it, and because my lovely face is in the way of my writing there, I'm going to scooch that back up. So you have a negative. I don't know why that did that. You have a negative 80 as your product, which means this is negative. So because this is negative, it means one of your numbers, one of your magic numbers, is positive, and it means the other one has to be negative. And when they add together, they have a difference of -2. So the larger of the two numbers is going to be the negative one because it ends up being negative overall when you add them together. So you're looking for a difference of 2. And hopefully you see that 8 and 10 have a difference of 2. So to know which one's negative, it has to be the larger one. So that means it's going to be -10 and +8. And you can double check. Is +8 times -10 -80? Yes. Is +8 plus -10 -2? Yes. Do I have to do any of this long crazy stuff that I did in the other section? No. I'm going to draw my factor brackets. I'm dealing with the variable x, so one x goes in this bracket, the other x goes in this bracket. Then all I have to do is fill in those lovely magic numbers I found. One was +8, so it's going to be +8 in one bracket. And the other one was a -10, so it's going to be -10 in the other bracket. And there I go, I've factored it out. Now, question. Is it possible, without asking your teacher or Bob, who I know you've all missed, is it possible without asking these wonderful things and people, if you're right, is there a way to know if you're right? Yes, there is. So what you can do, and I'm just going to remove my little square box around my whole rectangular box around to give myself more room, you can just re-expand. So if you have x plus 8 times x minus 10, and you want to know if that's the real answer, if that's right, and you have time, or you just want to know and Bob's not available and Miss Mackenzie's not available and no one wants to help you, you can do it on your own. So you take x and you multiply it by x, and you get x squared. And then you take x and you multiply it with -10, and you get -10x. And then you take 8 and you multiply it by x, and you get +8x. And then you take 8 again and you multiply it by -10, and you get -80. Run out of room. All right, and then you're not done. You have to group your like terms. Those look alike. Not anymore because something happened with my highlighter. They are like terms, so you are going to combine your like terms, collect your like terms, group your like terms. What are you going to call it? X squared minus 10x plus 8x is -2x minus 80. Is that the same expression we started out with? Meaning, does this look like this? Yes, it does. And we pat ourselves on the back. We get a warm, fuzzy feeling on the inside. Our brain releases some endorphins because we were correct, and we feel all good, warm, and fuzzy inside. And there we go. Take a break if you want. Come back. And we're just going to go over some additional factoring fun. See, factorings are fun, it's just like fractions. All right, so we're going to look at a different kind of thing. So remember when I said you always look to see if you could factor the 3 terms first before you do something? Example 2 is all about that. Okay, so if we look at 3x squared and negative 27x and 54, they don't all have x's, so you can't factor x out, but just look at the numbers. And here it really helps if you know your divisibility laws, but just see, can you divide the same number into all of them? Right now, you might be going, oh no, that number is not a 1. I have to do things the hard way. But if you can factor out that 3 and get rid of it and have a 1 in the A position, this is to your benefit because then you're not having to do decomposition method with larger factors and potentially be missing some simplification. So you always look to see, can you simplify by factoring out something in all 3 terms first? And here we are, we're going to go. So to know whether something is divisible by 3, you just add up all the digits within the number, and if that answer is divisible by 3, then it's divisible by 3. So for example, 27, if you add 2 plus 7, it's 9. Does 3 go into 9? Yes, that means that 3 goes into 27. Same with 54. If you add 5 plus 4, you also get 9. Does 3 divide into 9? Yes, yes it does, which means that 3 will divide into all 3 of these terms. So then you're going to take 3, remember your greatest common factor comes out, and what's left gets left in the bracket, just like lesson 1. So now you have a trinomial inside the bracket where the number in the A position is now a 1, okay? Which means you can use the simple magic number method, or it's actually called the product sum method, and just stick those numbers, those magic numbers, straight into the brackets. No decomp, no box method, no crisscross, none of that stuff, just straight in. So you're just gonna, if you see this 3 right here, just gonna ignore it for a little bit. Not gonna forget about it. We're just gonna push it off to the side because it's already kind of out there. All right, so now we're looking for 2 numbers that multiply to positive 18. And those same 2 numbers add to negative 9. Pause the video here and see if you can think of them. Welcome back. Okay, so the 2 numbers are going to be both negative because they have a positive product, but they add to a negative number. And so they have to multiply to 18. So you could list out all the factor pairs of 18 here, because there's an indefinite amount of ones that will add to negative 9. And you're going to find that the numbers are going to be negative 6 and negative 3. Is negative 6 times negative 3 18? Yes. Is negative 6 plus negative 3 negative 9? Yes. So instead of writing all of this, you're going to write those factor brackets. So this 3, we didn't forget about it. It still gets written down, but instead of all this stuff that's highlighted, we're going to write factor brackets. Our variable is an x, so we're going to write an x in both of the brackets. And then our 2 magic numbers are negative 6. So in one bracket, we're going to write negative 6. And in our other bracket, we're going to write negative 3. And we're done. Okay. This is our factored form of this expression. And of course, if we want to check our answers out, we could FOIL. And then we would FOIL the 2 brackets first, and then we would multiply everything by 3. I'd like you to pause the video now and try B. Welcome back. All right, so now we're going to look at these three terms. And oh, I spiced it up a little bit. It's not just a number that's the greatest common factor with these three terms. We got a variable too. So if you look at just the numbers, what number goes into 4 and 8? The answer is 4. If you did 2, you're not wrong, except for you're not using the largest greatest common factor, which means you're going to have to factor out another 2 somewhere else later down the road, and you might not catch it, which means you might not get as far as you need to with your answer. So you always want to factor out the greatest common factor, and this for the number is 4. But if you notice, all three terms also have x's. So the greatest common factor is a 4x. Now I'm just writing out 4x 3 times because I feel like it. Normally I'm super lazy and just draw a line across all of it. I don't even write it actually, but there's more than one way to indicate what I'm doing on a piece of paper or laptop. You know what I mean. All right, so the greatest common factor comes out. So if I'm going to divide 4x cubed by 4x. 4x cubed divided by 4x. The 4 and the 4 cancels out, leaves me with 1. Do I need to write the 1? No. And then if I have x cubed divided by x to the power of 1, remember our exponent laws, 3 minus 1 is x squared. I can take a moment and look, did I do that right? Is 4x times x squared the same thing as 4x cubed? Yes, so okay. Then I'm going to look at the second term here. I'm going to look at just the numbers. Negative 8 divided by 4 is negative 2. And then x squared divided by x to the power of 1, again, exponent law is 2 minus 1, so leaves me with 2x. And then 4x divided by 4x is not 0, it is positive 1. All right, so now here we go. We've got this 4x, kind of like that awkward third wheel. We're just going to push it off to the side and ignore it for a bit and look at just what's inside the brackets. If we look at just what's inside the brackets, we have another trinomial, and the number in the A position is another 1. Imagine that. It's like magic. All right, so now we're going to look for two numbers that multiply to 1 times 1, which is positive 1. And those same two magic numbers have to add to negative 2. Okay. So again, we have a positive product, which means both numbers have to be either both negative or both positive. They have to add to a negative sum, which means the numbers are going to be both negative. Pause the video here and see if you can figure them out. All right, welcome back. My pen decided to stop working, so I'm gonna use my finger. The writing's gonna just get worse from here, guys. I'm sorry. I'm not retaping this. I'm too far in. Too far in. Committed too much. So the number is negative 1 and negative 1. Ah, isn't that glorious? So we're not going to forget that this 4x exists. It's still here. But instead of writing all of this loveliness, we're going to write the factor brackets. All right. Because we're dealing with the exponent x, we're going to put one x in one bracket and the other x in the other bracket. If we were dealing with a's, we put one a in one bracket, another a in another bracket. All right, our two numbers is x minus 1 and x minus 1. You notice that what we have in the brackets is the exact same thing, so we could actually rewrite this if we wanted to as 4x times x minus 1 squared. All right. Last one. Some good times. So this one might look a little freakish, but really it's the same idea. We have, instead of it being x to the power of 2, or x squared as our highest exponent is x4. But if you notice, our middle term, my pen's still not working. We notice the middle term is still a squared, is still half the number of half the degree as what the highest degree is. So really, what we're going to end up doing isn't that much different. We're still going to, the number in the A position is still a 1, so we're still going to look for two numbers that multiply 20. And these two numbers will add to positive 9. Pause the video here and see if you can figure them out. Welcome back. Sounds, I don't know, I'm still getting used to doing this. All right, so the two numbers are 4 and 5. 4 times 5 is 20, and 4 plus 5 is 9. So you're still going to go straight to factor brackets. There's no need to overcomplicate this and do some crazy decomposition, or it's not even that crazy. I actually quite like decomp, but there's no necessary to add extra steps where potential errors can be put in. You can go straight to your factor brackets. But this time, instead of this just being an x, in each factor bracket, we need this x and this x to multiply to give us x to the power 4. Can we split that up evenly so it does that? Yes. So x squared is going to go in each one, okay? Because the middle term has an x squared, right? And now all we have to do is add those magic numbers, that we found and put them in the bracket. So the two numbers we found is positive 4, so it's going to be plus 4 in one bracket, and positive 5 in the second bracket. All right, so that concludes our lesson 2 in unit 3, the second one of these videos where the pen just decides, my stylus decided not to work, so hopefully you can still read my finger writing. And I'd like you guys to try the lesson 2 questions in the handout that has been provided. All right, let me know if you have any questions. Either email me, put a message on Teams, write in the chat, or come to one of my online office hours where I can write stuff on my whiteboard. Okay, hope you guys are all doing well, and take care.